There are discoveries that challenge our understanding of the universe. And then there are those that shake the very foundation of what we thought was possible. Imagine a visitor from the stars hurtling through our solar system at speeds that make our fastest rockets look like they're standing still. What if this cosmic traveler, captured in stunning detail by the most powerful telescope ever built, revealed secrets about worlds billions of light years away, secrets that could rewrite the story of how our own solar system was born? This isn't science fiction. This is 3I/ATLAS, the third confirmed interstellar comet to grace our skies, and the James Webb Space Telescope's jaw-dropping images are just the beginning. As we dive into this interstellar enigma, we'll uncover its blazing path, the bizarre chemistry bubbling from its core, and why it's got astronomers buzzing about ancient star systems and the building blocks of life. Stick around, because in the vast theater of space exploration, 3I/ATLAS isn't just passing by. It's dropping clues that could change everything we know about where we came from. Let's start at the beginning, because every great space story has one, and this one's got timing that's almost too perfect. On July 1st, 2025, a telescope in the crisp night air of Chile's Rio Hurtado Valley, part of NASA's Atlas survey, designed to hunt for near-Earth objects, spotted something odd streaking across the stars. It wasn't a typical comet looping lazily around our sun. No, this thing was on a one-way ticket from beyond our cosmic neighborhood. Digging into archives, astronomers traced its glow back to June 14th, captured by other scopes like Caltech's Zwicky Transient Facility. They named it 3I/ATLAS, the 3I nodding to its interstellar origins, following in the footsteps of the enigmatic Oumuamua in 2017 and Borisov in 2019. Fun fact, a TLAS stands for Asteroid Terrestrial Impact Last Alert System, but on this night it was sounding the alert for a guest from another star system altogether. Picture it like finding an unmarked envelope in your mailbox, postmarked from a galaxy far, far away. Why does this matter? Because interstellar objects like this are rare cosmic postcards, letting us peek at the chemistry and physics of distant stellar nurseries without leaving home. As 3I/ATLAS barreled in, its path told a tale of wild independence. Unlike the predictable ellipses of solar system comets, this one's trajectory is hyperbolic, a fancy way of saying it's not orbiting, it's just swinging through for a quick visit before slingshotting back to the void. It's coming from the direction of Sagittarius, that starry teapot in the summer sky, and it'll hit its closest point to the sun, its perihelion, around October 30th, 2025, at about 1.4 astronomical units away. That's roughly 130 million miles just inside Mars' orbit, close enough to heat things up, but not so near that it'll disintegrate like some sun grazers do. Its closest pass by Earth? A comfy 1.8 astronomical units, or 170 million miles. Farther than the distance to Venus at its nearest, so no worries about any doomsday scenarios. But here's where it gets thrilling. At discovery, it was clocking 137,000 miles per hour, or 61 kilometers per second, and that's only speeding up as the sun's gravity tugs it closer. To put that in perspective, if you hopped on 3I/ATLAS for a joyride to the moon, you'd get there in under 2 hours, faster than any human spacecraft has ever dreamed. This velocity isn't just impressive, it's a signature of its extrasolar roots, unbound by our sun's pull, whispering of the gravitational dance it left behind in some other star's embrace. Now zoom in on the star of the show. The James Webb Space Telescope, or JWST as we space nerds call it, perched a million miles from Earth, gazing deeper into the infrared than Hubble ever could. On August 6th, 2025, JWST turned its near-infrared spectrograph, NIR spec for short, toward our visitor, capturing light that stretched by the comet's insane speed and the cosmic dust in between. What it saw was a glowing coma, that fuzzy envelope of gas and dust around the nucleus, alive with outgassing as solar heat sublimates its ices. The data poured in: carbon dioxide, water vapor, water ice, on carbon monoxide, and even carbonyl sulfide, a sulfur-bearing molecule that's like a whiff of volcanic activity from space. But wait, there's more. Hubble had chimed in earlier, on July 21st, snapping a teardrop-shaped dust cocoon around a nucleus estimated between 1,444 feet and 3.5 miles across. That's bigger than Manhattan, and heavy enough to tip the scales at over 33 billion tons in some measurements. JWST's infrared eyes cut through the haze, revealing not just what's there, but how it's behaving, layer by layer. Imagine JWST as a cosmic chemist, sniffing the vapors and saying, this comet's got a recipe unlike any from our kitchen. And speaking of recipes, let's talk anomalies because 3I/ATLAS isn't playing by all the rules, and that's what keeps scientists up at night, in the best way. One head scratcher? The carbon dioxide to water ratio. In most comets we've studied, water dominates the outgassing show, but here CO2 is stealing the spotlight, clocking in at levels higher than anything observed before. Why? Theories point to its formation near the CO2 ice line in its home protoplanetary disk, where temperatures were just right, around 80 Kelvin for carbon dioxide to freeze solid while water stayed gaseous. Or maybe its core is unusually rich in dry ice, shielded somehow from the heat that usually vaporizes water first. Add to that its green hue, spotted in later images, a rare color from diatomic carbon molecules fluorescing under sunlight, like a cosmic emerald zipping through the black. Then there's the non-gravitational acceleration, tiny pushes from outgassing that tweak its path, but measurements suggest a mass that's anomalously huge for its brightness, hinting at a denser, rockier makeup than expected. Emitting nickel? Early spectra picked up traces, which is odd for a comet, but could mean it scooped up metallic bits from its stellar travels. Avi Loeb, the Harvard astrophysicist famous for Oumuamua theories, floated ideas of artificial origins, but Hubble and JWST data firmly peg it as a natural comet, active, icy, and very much a product of nature's wild lab. These quirks aren't red flags for aliens. They're invitations to rethink comet evolution across the galaxy. To appreciate 3I/ATLAS fully, we can't ignore its predecessors, those interstellar trailblazers that set the stage. Remember 1I/Oumuamua? That cigar-shaped oddball in 2017, tumbling silently with no coma, sparking endless debate about whether it was a fragment of a Pluto-like world or something more exotic. It accelerated weirdly too, but without the gas jets to explain it fully. Then 2I/Borisov in 2019 burst onto the scene with a classic comet tale, rich in familiar ices, proving interstellar visitors could look a lot like homegrown ones. 3I/ATLAS bridges them, active like Borisov, but with Oumuamua's anomalous vibes in its mass and chemistry. Side by side, they form a trio sampling different corners of the Milky Way, Oumuamua from the thin disk, Borisov from the thick, and 3I/ATLAS possibly from that ancient 7 billion-year-old layer of stars we call the galactic thick disk. Compare their speeds, all over 100,000 miles per hour, but Atlas edges out with its 137,000. Sizes? Oumuamua was puny at 800 feet, Borisov around a kilometer. Atlas dwarfs them at up to 3.5 miles. Chemically, while Borisov mirrored solar system comets, Atlas's CO2 dominance suggests star systems where carbon rules the roost, maybe hotter, drier bursts than ours. It's like collecting stamps from alien mailboxes. Each one unique, each one teaching us the universe recycles its scraps in endlessly creative ways. But why chase these speed demons at all? Beyond the wow factor, 3I/ATLAS is a time capsule hurtling from the galaxy's attic. At potentially 7 billion years old, it's older than our sun by billions. Formed when the Milky Way was young and wild, its ice is locking in the raw materials of planet formation from eons ago. That high CO2, it hints at protoplanetary disks where carbon compounds dominated, perhaps leading to worlds with diamond rains or methane seas. not the water worlds we favor for life. Carbonyl sulfide, meanwhile, is a prebiotic molecule, stuff that could spark organic chemistry, the same as in comets that may have seeded Earth with life's ingredients. NASA's fleet is all over this. Tests spotting its transits, Swift measuring X-rays from solar-wind interactions, Sphere-X mapping its infrared glow, even Perseverance on Mars snapping pics from the red planet's surface on October 4th, 2025. Future implications? Missions like ESA's Comet Interceptor could one day rendezvous with such wanderers, scooping samples mid-flight. And for interstellar travel dreams, think breakthrough starshot. Understanding these objects' durability at warp speeds is gold. In a universe teeming with trillions of stars, 3I/ATLAS reminds us we're not isolated. We're part of a grand exchange, trading cosmic debris like neighbors at a block party. As we watch 3I/ATLAS fade toward the sun's glare, peaking in brightness late October before vanishing into the outer dark, it's worth pausing on the bigger picture. This comet isn't just data points on a graph. It's a bridge between here and there, challenging us to expand our view of habitability, origins, and the sheer diversity of the cosmos. We've learned its ice's whisper of carbon-rich births. Its anomalies push us to refine models of outgassing and acceleration, and its passage unites global teams in real-time wonder, from Chilean telescopes to Namibian arrays. Key takeaways? Interstellar objects are more common than we thought. Maybe one per year zipping unseen through our system, and each one peels back layers of galactic history. But here's a thought-provoker. If 3I/ATLAS formed in a disk where CO2 ruled, what does that say about the odds of Earth-like worlds elsewhere? Could carbon-heavy systems host silicon-based life, or exotic biochemistries we can't even dream up? And with thousands more waiting in the wings, are we ready for the next visitor? And what stories will it tell? If this interstellar adventure has you starry-eyed, hit that like button to fuel more space deep dives, subscribe for updates on JWST's latest cosmic portraits, and drop a comment. What's your wildest theory on what 3I/ATLAS is carrying in its icy heart? Check out our video on Oumuamua's mysteries next, or the Borisov breakdown for the full trilogy. Thanks for exploring the universe with me. Until the next wanderer calls, keep looking up.